So this is the second example on velocity in mechanisms. To watch the solution of the first example, do well to look at the description of this video and you'll find a link to that amazing video. Now let's consider this question. It says, the angular velocity of crank OA is 600 rpm. Determine the linear velocity of the slider D and the angular velocity of the link BD when the crank is inclined at an angle of 75 degrees to the vertical. The dimension of various links are OA equals 28 mm, AB equals 44 mm, BC equals 49 mm, BD equals 46 mm. The central distance between the center of rotation O and C is 65 mm. The path of travel of the slider is 11 cm below the fixed point C. The slider moves along a horizontal path and OC is vertical. Okay, so this is a link given to us here. Like I said in the previous video, our first task will be to take some suitable scale and reproduce this link. Okay, so let's start by reproducing the link. We are given C to O, and from the question, C to O is equal to 65 millimeter. Okay, from O to C is 65 millimeter. So which means this distance is 65 millimeter. This is 65 millimeter. Similarly, we were told that OA is 28 millimeter. From O to A is 28 millimeter. So here is 28 millimeter. We are also told that from A to B is 44 millimeter. So from A to B here is 44 millimeter. Also, we are told that from B to C is 49 millimeter. This is from B to C, and here is 49 millimeter. And we were told that from B to D is 46 millimeter. This is from B to D, so here is 46 millimeter. And once more, they said the question says the path of travel of the slider is 11 centimeter below the fixed point C. So which means this point below the fixed point C, from point C to this point, is given simply as 11 centimeter. All right, so those are the dimensions. So we are going to be taking a suitable scale now, and we are going to be using a suitable scale to draw the link itself. That's the first thing to do. The first thing is to draw the link. So we'll simply say, of course, okay, we are simply dividing each of them by 10, right, to make it smaller, or converting it to centimeter. You simply divide by 10 to convert to centimeter. So the scale is in order. All we need to do is divide each of the sides by 10. So you can simply say 1 centimeter is equivalent to 10 millimeter, right? So how many centimeter is going to be 65 millimeter? This is your scale. If you cross multiply, 65 times 1 centimeter remains 65, okay, millimeter, and that's going to be x times 10 millimeter. Here gives us 10x in centimeter, right? So to make x subject, x becomes what? 65 divided by 10. So which means x is going to be what? 6.5. So which means 6.5 centimeter. So this simply means we are dividing all the sides by 10, so that we can easily plot them using the meter rule. So if you divide 65 by 10, that gives you 6.5. So it means that this length from C to O is actually 6.5 centimeter. So we maintain the same thing all through. That's our scale. Okay, so let's draw the diagram now and see. So from O to C is actually 65, which is 6.5. So you pick your meter rule and you measure out 6.5. You pick your meter rule. Okay, you pick your meter rule. So let's measure out 6.5 and see. So this is 1, 2, 3, 4, 5, 6. So 6.5 is directly at the middle. So 6.5 is directly at the middle. So you simply trace down to this point. Okay, you have this. All right, so that is O and C. Now, not forgetting, in the question it was stated that The crank is inclined at an angle of 75 degrees to the vertical. So as can be seen, you have 75 degrees to the vertical. So from O to C is at 75 degrees. So that means you will be needing your compass. Okay, you pick up your compass and you place it directly here. So let's keep it this way. We can get an accurate measurement since the angle is towards this side. So you simply keep it this way. Let the 90 degrees line be on the same mark as this line. Okay. So we need to measure out angle 75 degrees. So observe that this is 90, this is 80, this is 70. So which means I counted 2 to get to 70. So the middle will become 75 degrees. So if here is 90, this is going to be 80, this is going to be 70. That means 75 should be at the middle, right? So this is 90, this is going to be 80, is going to be 70. So 75 should be somewhere at the middle. Okay, because the angle is facing this other way and not the other way around. Okay. So 75 should be somewhere here at the middle. So you can just make a point there and you leave, right? Now you join this point. You don't really know the dimension yet. You're not drawing with the dimension yet. So you can simply just join from point A, draw a faint line to connect to this point. Just draw a very faint line before taking the measurement. So from point O, you simply draw a faint line to connect this angle. Since you're not yet taking measurements, so you're going to be using a faint line first. Okay, so you draw a faint line and you keep it that way. All right, now let's get the measurement. Remember, this is point C. This is point C. And this is point O. So let's get the measurements. This angle now has been found. This is angle 75. But then let's get the measurement from O to A is giving us 28 millimeter, which is invariably 2.8. Simply divide by 10. That gives us 2.8. So you pick up your meter rule and you measure 2.8 from that point directly on the line. So you measure out 2.8. So okay, so the initial points join together. So this is 1, this is 2. 2.8 is just 2 centimeter close to 3. So you have it somewhere around here. Okay, so you join with a thick line. All right. So this is now point A from the diagram. This is now point A. So you have there to be point A. Not forgetting the angle here is 75 degrees. Okay. Now we need to find point B. You observe that point B is also linked. We need to find point B, but you observe that point B is also linked to point C. So what you need to do now is pick up this distance from A to B. Now you're going to be needing your protractor. So you pick up your protractor. Okay. You pick up your protractor and you measure the total distance from A to B. It was given as 44 millimeter. From A to B was given as 44 millimeter. So that is going to be 4.4 meters. You pick your meter rule, measure out 4.4. Okay. So you keep your meter rule. You measure 4.4 should be just 1 centimeter to 4.5 being the center. This is 1, 2, 3, 4, and this is 4.4 just by the center. And you have this extend to this point, so you have this to be 4.4. All right, so we have our 4.4. You simply place this at point A. You simply place this at point A, and then you make an arc. You make an arc. Next, you move over to point B to C. B to C is 49 millimeter, which is around 4.9 centimeter. So you measure out 4.9 using your protractor and your ruler. So 4.9 should be just 1 centimeter to 4.9 should be 1 centimeter to 5.0 centimeter. So you have here, this is 1, 2, 3, 4, and this is 5. So 4.9 is just 1 centimeter away, and you have this. All right. So this is 4.9. Now you place at point C. So you bisect the line and you have this. So you join the 2 points now at the point of intersection. So this is the point of intersection. Now you join the points, join point A to this point. So you join these 2 points together and you have this. Similarly, you join point C to point B and you have this. Okay, so we are almost there. Now we measure out A to B to D, which is the slider. Measure out B to D, and B to D was given to us as 46 millimeter. That's going to be 4.6 centimeter, right? Okay, so it was stated that the slider moves horizontally and the height of the slider to point C is simply 11 millimeter. That's around 1.1 centimeter. So you simply measure out 1.1 centimeter okay, from point C. So you simply measure 1.1. Okay, so this is 1.1 is here. You have this. All right. The next thing to do is we need to now find point D. Okay, from here to this point is 46 millimeter. From point B to point D, from point B to point D is given as 46 millimeter. That is going to be around 4.6 centimeter. So now you also use your protractor and your ruler, measure out 4.6. So this is my meter rule. 4.6 is just 1 centimeter after 4.5. So this is 1, 2, 3, 4. 4.5 is at the center. So 1 centimeter after that, you have here. So this is 4.6. Okay. So that's 4.6. So you pin at point B. Not forgetting this is point B. And this is A. This is point B now. Not forgetting. So you pin at point B. You pin at point B and you make an arc. You make an arc. Now, you simply pin at point, okay, from C to this last point, on this point, although it wasn't given, it wasn't really specified from the diagram, there was no specific point there. So simply pin at that point again. This time around, you extend a little bit because there was no this thing specifying their distance. So just simply extend horizontally. Since the motion is purely horizontal, then you bisect. Okay, now you join the points together. You join the point of intersections together. Okay, you have this. Then you simply join these 2 points again. All right. So that's the first task achieved, being able to redraw the diagrams. Now, the next thing we need to do is calculate the velocity of the point that is known. In the question, we were told that the angular velocity of OA is 600 rpm. So this OA has an angular speed of 600 rpm. So that means that the angular speed NOA is equal to 600 rpm. We need to now find the velocity of the known point. But before doing that, we have to find the angular velocity omega. Omega itself is 2 pi n OA all over 60. So this is going to be 2. Pi is 3.142. N now is 600. 600 divided by 60. So this implies that the angular speed along OA is now going to be equal to, so 2 pi n is 600 divided by 60. That gives us 62.83 in radian per second. Therefore, the velocity of that link OA is going to be angular speed OA multiplied by the distance along OA. So velocity, linear velocity of OA is going to be angular speed is 62.83 multiplied by the distance along OA. In the question, it was given as 28 millimeter, which is simply 28 divides 1000, and that will give us 0.028. So this simply implies that the velocity of arm OA is going to be equal to multiply 0.028. So this gives us approximately 1.76 meters per second. So this is the velocity or the known velocity of link OA. So you cannot solve using the velocity diagram if you don't know at least one velocity. So now we know this velocity, and from the question, the direction was also given. And from the question, the direction was also given. It is moving in this direction. So which means I'm going to be having a velocity which is at 90 degrees to this link OA, and it must be in the same direction as direction of motion. So this is 90 degrees to the link. So I have my velocity pointing in this direction. This is velocity at A, okay? And it must be at 90 degrees and in the direction of motion. So which means from A, I have a speed that is at 90 degrees to the arm OA, which is this. And this is simply VA. So having known this velocity now, we have to now plot the velocity diagram, and that is how we are able to find the other velocities. So to do that, first of all, we pick out a fixed position, the fixed point. Point C and point O are fixed, not forgetting. These 2 points are fixed, not forgetting. These 2 points are fixed. So you simply pick out a fixed point. You can simply call here the fixed point. This is now O, comma C. So simply use small letters for that, O, comma C. Those are the fixed points. Now, you have to now draw this velocity vector, which is at 90 degrees from the fixed point. But in order to do this, you have to get an accurate scale, a proper scale for 1.76, because 1.76 is going to be quite small for us to draw using our meter rule. So we simply either multiply this velocity by 2 to just improve it a little bit. So we are simply going to be using a scale of, so we are simply going to make use of a scale of, we can use this scale 1 centimeter to be equal to 2 meters per second. I'm sorry, 1 meters per second. Okay, 1 meter per second to be equal to 2 centimeter. Okay, therefore, what will 1.76 meters per second be? That's x. And if you cross multiply, you have 1.76 multiplying by 2. So this simply means that x is going to be equal to 1.76 times 2. So this is 3.52 meter per second. So this is now the velocity we are going to be using via the scale 3.52. So which means we are multiplying all velocities by 2. So whenever we are done with our velocity diagram and we obtain the velocity which we have been asked to find, all we need to do now is to divide that value by 2 to get back its original value. So that means instead of 1.76, we are now simply saying velocity along OA is equal to 3.52 meters per second. So simply multiply it by 2. Now you measure out 3.52 and it must be inclined just the way it is here. So this is the 90 degrees pointing downwards. So 90 degrees, you move it here, pointing downwards, and the value is 3.52. This is okay. This is 1, 2, 3. 3.5 is the middle. 3.52 is just 2 inch after that, or 2 centimeter after that, and you have this. All right. So this is our velocity from O to A. So this is from O to A. That means, remember, here is the fixed point OA. So which means from O, you have here to be A. So this point is simply point A. Okay. Now from A, all you need to do now is keep drawing perpendicular lines to each of the link. Okay, so from A, perpendicular line is simply this. This is what makes an angle of 90 degrees to this arm A to B. So from A to B, you draw perpendicular line at 90 degrees to this link AB. So let's move this a little bit close. This is 90 degrees, and this is point A, remember? So from point A, 90 degrees. This is what I have, 90 degrees to AB. So this is point A. In this case now, simply draw faint line because we don't know the next dimension. So you can simply draw faint line. Easily use a different colored pen. Just draw faint line, something like this, because we don't know the next dimension. We don't even know what we are doing at this point. We're just simply replacing or tracing 90 degrees from each point. So I've done from A to B. 90 degrees is simply yes, which means if this is A, either down is going to be B or up is going to be somewhere along, either up or down is going to be B, but we're going to find out. Now, after that, from point B to point C, you find out that I have 90 degrees in this direction, which is going to connect to point O, or the fixed point. So I have this is 90 degrees. So if I trace this now, this is the fixed point O, this is the fixed point. So if I trace this from here to this point, this is 90 degrees. So I can now join this with a thick line because now I am going to have a real dimension for B. So this can be joined with a thick line. All right, so you now see that I can simply trace from here now to this point. All right, so that means this is now point B. So here is my point B. You note that with a small letter. This is point B. Not forgetting. Okay, we can trash this. This is OA. Okay, this is O, comma C. OC, please. The fixed point. Okay, you can either discard this OC. So that means this is from A to B. Now this is now from B to the fixed point. Now this is from B to point C. Now this velocity to the fixed point is simply called VB. Velocity along this arm is simply called VB. Okay. Having obtained this, again from point B, again from the fixed point relative to point C, I can have 90 degrees in this direction. So all you need to do is simply just draw 90 degrees line from each of the links. That's all. So from the fixed point relative to point C, which is from O relative to C, I can draw 90 degrees. This is 90 degrees. So you see this corresponds also to this point. So you can just simply hold it. This is 90 degrees. This is 90 to this arm. Okay, this is 90. Hold it to this point, and then you draw faint line. Because you don't know where they are meeting, you simply draw faint line, and you have this. Similarly, from point B to point D, also draw 90 degrees. This is 90 degrees. Yes, this is 90 degrees. This is 90 degrees. So you move that now to point B and join. Let's see where it's going to meet. Okay, you move this now to point B. This is point B. 90 degrees is here. This is point B. Okay, so you simply join. Let's confirm this again. This is 90. This is 90. You can join with a thick line. So this is where they intersect one another. This is also where they intersect one another. Now you can join with a tick. line. Okay, so this becomes the velocity diagram. All right, so this is now this is point D. Okay, this is going to be point D. So that's point D. So measuring from B to D, which is from B to D, you have that. Now, the velocity that connects to the fixed point are called V, like in this case now, from B to the fixed point is simply called VB. Similarly, from D to the fixed point is called VD. So this is VD. This is velocity at point D. And this that connect to the fixed point from B is simply VB, velocity at point B. So in order to find these velocities, you have to employ your protractor once more, or you can simply use meter rule to measure. You can simply place your meter rule there to measure, but I prefer to use my protractor because it makes it easier for me. But you can simply place your meter rule there and measure. It's still the same thing. Okay. So the question says we should find velocity at point D and also find the angular velocity of the link BD. So in order to find velocity at point D, we have to measure distance from D to the fixed point. This is the velocity at point D. So you simply measure from here to the fixed point and you have this. So you take this measurement now and you place it on your meter rule. This is your meter rule. Let's figure out what we have. So this gives us approximately 3.2. Okay, so velocity at point D gives us 3.2. All right, so VD gave us 3.2 meters per second. But remember the scale we took earlier, we had to multiply all the sides by 2. So which means we are going to be dividing this by 2. So this is going to be 3.2 divided by 2. This simply implies that velocity at point D is going to be 3.2 divided by 2. That simply gives us 1.6 meters per second. So this is the true velocity at point D, 1.6 meters per second. You can also measure using the meter rule. Okay, you can simply place your meter rule and you can also measure it out and you have the same result. Okay, next is to find the next question. So we should find the angular speed along BD. In order to find the angular speed along BD, you have to find the velocity of link B to D. So from this point to this point, you find the velocity of that arm. So you can once more either use your meter rule or you can simply use the protractor. I prefer to use my protractor. Okay, so you measure from here to this point, then you trace it out on the meter rule. Let's see how many this gives us. So this measures around 3.4 meters per second. This measures around 3.4 meters per second. Okay, so it means that the relative speed VBD is actually 3.4 meters per second. So remember, you have to divide it by 2. This simply implies that relative speed from B to D is going to be equal to 3.4 divided by 2. 3.4 divided by 2. This gives us 1.7 meters per second. But we are told to find the angular speed. You remember the relationship between angular speed and linear speed? V, or in this case VBD, is going to be omega BD times the distance between B and D. So which means if I make the angular speed omega BD subject, I'm going to have VBD divided by the distance between B and D. But what is now the distance between BD from the question? Distance from B to D is given as 46 millimeter, which we have to divide it by 1000 to convert to meters. That's 46 divided 1000, which gives us about 0.046 in meters. All right, so this simply implies now that we can now make omega be the subject. This is going to be 1.7, which is VBD, divided by 0.046. So this simply implies that the angular speed along B to D is going to be equal to, so we have 1.7 divides 0.046. That simply gives us 36.96. We have 36.96 radian per second. So that becomes the angular speed. Okay. So that becomes the angular speed of the link B to D. All right, guys. So that's how to solve velocity in mechanisms problem using velocity diagram. In the next video, we are going to be looking at governors in theory of machines. I know you want to be a part of that video, so do well to hit the subscribe button right now. Turn on your notification bell so you don't miss out on that video when it drops. Don't forget to like this video, comment nicely, and share to your friends. I will see you in the next video. Thanks.